What if a single math formula could save a life? Today, we are going to be talking about Bayes' theorem. Bayes' theorem revolutionized science by giving us formal method to update beliefs with evidence, medicine, genetics, forensic law, artificial intelligence, physics, neuroscience and psychology, and the everyday decision making. Our main focus here is in the medicine field. In 2020, my grandfather had a heavy cough. We thought it was just common cold. So we rushed him into the hospital, and the doctors and nurses immediately started testing him for COVID. The doctors didn't do a confirmation test, which was very crucial to my grandfather.
He lived in a small town in Cameroon, where only about 1% of the population had COVID. Thus, the chance for him to have COVID was already very low.
Our objective is to calculate the probability of someone to actually have COVID even though he was tested positive. The test itself was 90% positive, meaning the remaining 10% were the false positive. Set P of A being the probability of a random person to have COVID, P of A prime being the probability of a random person to not have COVID, P of B the probability of a random person to have a positive test, and P of B given A the probability of having a positive test given that you have COVID. Assume P of A given A is equal to 0.9, P of A is equal to 0.01, P of A prime is equal to 0.99, P of B given A prime is equal to 0.1. The probability of having a positive test in general can be calculated using the law of total probabilities. Considering the partition having COVID and not having COVID, the law of total probability says that the probability for you to actually have a positive test is equal to P of B given A times P of A plus P of B given A prime times P of A prime. Substituting the data we have give us 0.9 times 0.01 plus 0.1 times 0.99. Coming back to Bayes' theorem, P of A given B is equals to P of B given A dot P of A divided by P of B. As we calculated earlier, P of B is equals to 0.108. Substituting the above information we had, we give us 0.9 times 0.01, all that divided by 0.108, which will give us an approximate value of 0.083. Hence, the probability for you to have COVID, given that you had a positive test, is actually 8.3%. This is the story of how math saves lives.